So, very good morning, everyone. And it's my pleasure to welcome you all to sport that is defining meaningful innovation. So, I hope you might have heard the term voice biometrics. So, for those who haven't, basically, it is a science of using a person's voice as a uniquely identifying biological characteristics. And in order to basically authenticate them. And I think it sounds interesting, right? So, like to explain it further, that is the role of voice biometrics in improving customer communication. I would like to welcome our next speaker. He is Dr. Inderjeet Singh. He is a cybersecurity specialist, notable industry speaker, an innovator, and an influencer with proven success in spread-heading strategic information security initiative. He has experience of more than 29 years across wide spectrums of area, spanning cybersecurity operations leadership. And throughout his career, he has parlayed in extensive background in security and deep knowledge to help organizations build as well as implement strategic cybersecurity solutions. Now, so please join me in welcoming Dr. Inderjeet Singh. So the stage is yours, sir.
Yeah, thank you, Dheeraj, and thank you, Spot, SP Hot, for the wonderful, innovative discussions what you are planning to have. So to begin, I will just share my screen. If please tell me if you're able to see it. Right. Yeah. Can you see my screen?
Yes, sir. It's visible.
Okay. Perfect. So great. So, like what Dheeraj just brought out about voice biometric, voice authentication, and that's the way forward, what we are seeing ahead in the arena of authentication. And lots of direction happening in the last couple of years, and especially COVID, it changed the complete game when we were all, just going on your finger, biometric and trying to authenticate a person. But now the iris. But now what we are actually looking at is the facial and the voice. And the voice is, of course, one of the kind of very robust methodology for authenticating a person whenever you are there, either for your banks or your, any transactions what you're doing, you can authenticate using voice. And one question which comes to everyone, is voice cannot be spoofed? It cannot. It can be copied. The answer is a big no. The AI, machine learning, and the deep learning algorithms which are there are a big game changer in the field of voice biometric, and lots of research has happened in this area. And what we are going to be talking of is how the voice biometric really works, how it really improves the customer communication. So that's where we look at. So whenever you're going to any site of bank and you see, or any BPO, you're really frustrated, right? And what are you frustrated about? You're not frustrated about the company or the bank or the organization or the BPO, but you're frustrated about the authentication method, right? And that's 85% of the people are, kind of frustrated by that. And find a failing authentication, because what happens is that not all authentications pass. So some questions which people ask, you get a bouncer, you don't remember maybe your date of birth or your number or your secret number. So it's a really very frustrating. And you are being told to reset your password or PIN at least once a month. And how many combination and permutations of PIN you can have today? It's really phenomenal. At an average in your lifetime, a normal human being is going to have 130, accounts you're going to maintain. And if you have to remember the passwords of everything, it's humanly impossible. And that's what we always are challenged today. So what's really happening? What are we really looking in for? Right? We are looking in for voice biometric. And if I ask, and there's a survey which has been done, 90% of the people really want voice biometric as they go ahead for authentication. Just to give you from academic side, there are 5 kinds of biometric system which we have. One, fingerprint, we all know. Iris is second one. Palm geometry is the one, and the lower one are the face and the voice. Today, I'm only going to be touching on the voice, though a multimodal way of voice and face is the best combination for authenticating anyone. So even if you're going to do KYC in due course of time with your banks, with your BPOs, or any other organization which you're going to be working, you will have that eKYC, which would be a multimodal. So single mode authentication is not the preferred way. And the disadvantages of the existing system, what are they? So practically, if you look at it, is what you know and what you have. And what you know is your OTP, your personal information, maybe your date of birth, your ID number, your name. That's the what you know. Your transactional information, and what you may have. You may have the security tokens with you. You may have passport with you. You may have cards with you. You may have a RFID with you. But the pitfall is what you know is easy to forget, and data can be accessed by others. And especially when we read through the social engineering part, that really is a challenge. And in case of what you have is easy to lose. You can lose your security tokens, you can lose your passports, you can lose your car, and things can be stolen. So what are you looking in at? You're looking in at a kind of uh, balance between both hybrid comfort and security. And that is what is the next course. What we are seeing is in the identity verification. And as we look at the voice today, we seeing so much of Alexas coming into our home, right? So much of Google Assistants which are there. So 60% of the people believe that voice assistant add to convenience in their life, and there are more than 30% of the Google searches on mobile are voice driven today, right? And this is growing every day as we are talking. And 72% of the people who own smart speakers say the device are the part of their daily routine and from morning to evening. And in fact, to tell you, most of the places where Alexa is there in the house is actually a human being who's added to your house. So you, because she responds to the way you're talking. And try that, because the emotional AI and the conversational AI, which is part of the Alexa, gives you sometimes a very absurd answers which you're not wanting, right? And there is a huge traction when we are seeing in this area of the voice altogether, and that's why Google, Facebook, Amazon, all are going onto the voice, right? And why voice biometric? Why we are talking about the voice biometric? And like I told you initially, that you may have a first question in your mind that it can be spoofed. It's not a kind of robust, but I will tell you how it's a robust one. How is the best way ahead? When you go as a voice biometric part, because it's unique to each person, just like your fingerprint or iris. Okay, and it cannot be changed. And what it does is it encompasses individuals' respiration, soft tissue cavities, specific mouth and jaw movements produce a voice pattern which is distinctive pitch, dynamic, instantly intensity, which is very unique, altogether forming an individual voice print. And when we do a voice biometric, it's not just what we see and hear. We do almost 80 points in conducting the voice biometric in the backend. So there are two methods of doing a voice authentication. One would be a text independent, where you have authentication which is performed by analyzing any speech text which is there, content by the user. And second is a text dependent, where it is a system that requires user to say a fixed or randomized unique passphrase. So, and these are the text independent and text dependent are the ones are used to authenticate a user whenever he comes onto the system. So how does it work? It practically picks up your behavioral characteristics and your physical characteristics. And what are your behavioral characteristics? That's the pronunciation, your emphasis, speed of speech, accent altogether. And what are your physical characteristics? They combine a combination of unique physical traits of your vocal tract, mouth shape, size, and nasal phases. So that's make you unique, and that gives you a unique voice pattern for individual. When we are doing it. And what practically happens is, whenever you have the voice which comes up, you have an input speech. There's a feature extraction algorithm which is placed, and which extracts the information and creates the speaker's model and imposter's model, right? In case you're an imposter, it will negate it. And the speaker's model and the imposter's model will be again put through the algorithm. That's the deep learning algorithm, where we take a decision whether to accept or reject the speech which is coming from the user to authenticate, right? So the steps, what we do is, you know, it first processes your voice input to extract the characteristics that are specific to the speaker, and it builds up a statistical model which is known as the voice print or voice signature. And to verify a new input against an enrolled voice, which is already, like I told you, text independent and text dependent, same process is repeated and a similarity measure is obtained by matching the pattern. So we really match the code. So the algorithm, you remember, I'm not keeping your voice as a sample. I'm keeping the voice in the form of a mathematical algorithm, right? And I match the pattern. Okay, so there is no chance of your PII, because that's again a challenge which people talk of, is a personal identifiable information. How am I keeping it, right? So we are not keeping any voice as it is. We are keeping, converting into the mathematical algorithm and keeping it and storing it and matching it whenever, whenever a user comes up. And the voice input includes characteristics that relate to the way you're speaking, your lungs, the way they function, where you're talking, and how the airflow is affected, by the shape of your vocal tract. So that is how every sample is collected. And like I told you, there is almost 80 points in your mouth which are being, tracked when you do the voice biometric. And your voice biometric system closely relates to your physical characteristics of the speaker's vocal tract, right? And there are voice biometric engines that are designed to deal with variability. So we look into that. In case there is a cold and sounds different to another person, and there's a engine which already works, which can detect that these are two sounds which are, same. And it's a AI based voice recognition systems which are there in the market today. Lots of research is happening in this area, which can reduce the error rates to 2% at a signal to noise SNR ratio of 10 dB or higher. So just see how accurate these systems are becoming now and the way forward. Getting into some of technology, I thought let me give you a perspective over the technology as to how it really works. So you have a text independent and text dependent features which are there. So in the text dependent, we use hidden Markov model is being used, and in the text independent, we are using the vector quantization. That is how we see the sample. So you see, this is the voice. Whenever any person speaks, you have the frequency, you have the waveform, you have the amplitude of the sound whichever has been spoken. And when you see a waveform, say for example you speak a word sample, and I speak a word sample, and I again speak a word sample, it will look different when you're looking in from the same word, because the amplitudes are different. But what we are trying to do is we are matching the frequencies as well, and we are trying to plot a frequency time plot. And if you look at it, both of them, right, any frequency occurrence which is happening within a given time interval, they're almost same, right? And this is how we try to match the voice of a person. Okay, so this may not sound the best way of amplitude, but we are getting into the frequency part of it. And hereafter we do the NLP and the deep learning algorithm to actually identify the voice. And this is how you do the speaker identification, and it allows you to perform fast one-on-one speaker verification. And in case you have 1 is to n is to m speaker identification, you can do that as well, because that is how it really works. And all the voice identification are text independent, they're channel independent, they're accent independent. So you can have any of those, and they are language independent. And like I told you, there are lots of deep learning algorithms which are there, which generate highly representative mathematical model of human voice. and that is what is called the voice prints, and they offer extremely higher speaker recognition accuracy and the speed. And based on the input formats, you can have the output formats in different form, and the output is in the form of the XML or the JSML format, for with all the results which you're looking in for, right? And that is how you save the results. And the input is generally 8-bit, 16-bit wave or a raw, what we are speaking, that's how it really picks up. So voice biometric is where you don't require any sensors, you don't require any hardware additional. Only thing is you require the software to authenticate a person, and the database to, where you can do 1:n or n is to m verification. There are various solution scenarios which you can implement, different areas you can implement. It's quite cheap as compared to other methodologies which are there, quite comfortable and quite natural, because like I told you, you don't really remember anything upfront, and that's what is the natural speaking which is there. So it can help you in the identity verification, where you can have access control, biometric pin where you're using, and password resets. So you can use that. And in identification is where you can go in for the fraud detection and service personalization. So these are the areas which it helps you. And you can have a mobile app authentication. You works pretty good as a call center authentication world over. There are organizations, banks which are using voice authentication. In one of the countries, the complete pensioners, they have been given the pension based on the voice authentication, because every year the pensioners do have to authenticate whether they are alive or not. Similarly, in some of the banks in Europe and in US, where they're authenticating people for getting the services, right? So whether it's your password reset, your secure web payment, high risk card transactions, or employee to employee ID validation, you can all do it using the voice biometric. And the use cases could be call centers, your financial services, your healthcare services, government, identity as a service, of course, and online education, and plenty more. This is only from the very high level, 30,000 feet, which I'm telling you. Just to give you the example of how the present day authentication works when you go to the BPO or a call center uh, with the voice authentication. So I'll just play this video. Tell me if you get the sound. If you're not, let me just check what we can do. Are you able to listen to it? So this is first one is the old school thought which is there, where it is asking about introduce yourself, and quite time consuming, asking the date of birth, your card number. Now that guy is all, thinking, biting his nails as to what's the card number. Thereafter, your ID card details. Again, he's, confused. And now your secret word. And thereafter, after 1.5 minutes, where the call center person actually tries to give you the service. And this is what is the voice print, how it becomes very unique. One, it is impossible to falsify. It can be used for remote verification. And now just see how it's really happening. And it says, just introduce yourself, but just by the name, and what could be maybe, like I told you, text dependent, independent. And within 30 seconds, you're able to get the services. And this is what it is. In the old school, you had almost the verification time, which was so long, and now you're using the time for the solution. And these are the advantages what you get. And cost of service is so low. And the customer experience is really phenomenal when it comes to the voice biometric. Okay. So, wherever these kind of projects have been implemented, they have saved a lot of money, because customers' time and the company's time is precious. So they are able to service large number of customers in that precious time, and the customer is always very happy because he gets the services without much of hassle, right? And it's really helped a lot of companies saving a lot of revenue of theirs. And some bit of advantages about the voice biometric: it's a low cost of implementation, ease of use, and its rate of adoption is really increasing because the voice is natural to us. It's not a real big challenge. Anybody can be authenticated remotely, and the person doesn't need any physical presence to be authenticated, like your iris or your fingerprint. And it's quickly to enroll a person. You can do that in a voice authentication service. Just you have to speak that passphrase, text independent or text dependent, and it's just 2 to 8 seconds of speech that identifies you. And the authentication is pretty fast. It can happen within less than zero point 0.5 seconds. That's the kind of thing. And like I was telling you, all the AI engines are being used today to kind of improve upon the quality and the false ratio. Yeah. So this is I've already covered, I think. And some point I want to just cover on the security part of it. Um, like today, what they try to do is the fraudsters pretend to be as a client. There's a relative calling a client. Then you can have the fraudsters, who stole the client's ID and took loan from client's name. That is also possible because it's very difficult to authenticate, and you have accredited employees are calling for a legal entity. So in this case, a type of cases which are what are happening in the contact centers, voice biometric plays a major role, in overcoming these kind of threats that they're facing in every day, right? And like the cybersecurity part of it also is taken care of, where we have replay attack or cut and paste attack or recorded message attack. Or you may have a professional actor who may try to imitate your voice. Where you may have nasalization tempering, that's text to speech synthesis, which may base on the target speakers or the voice conversion. So people try to do all those methodologies, but what we are seeing is the voice biometric is a way ahead, and it really counters all these challenges which I showed you in the last two slides, to give a very seamless service to the customers in the contact center. So I'll stop here. If you have any question, it will be a pleasure to take it on. And you can reach me out on my LinkedIn. I'm available. We can connect up. It will be a pleasure. Over to you, Dheeraj.
Thank you, sir. Thank you very much. Like in this era of personalization and security, basically voice biometrics plays a very vital role. And thank you for explaining in terms of a mathematical algorithm as well, explaining different factors to it. And it was really an enriching experience for me as well as I hope for the participants also. So if anyone has a question, so they can put in a Q&A chat, and or so let's give them a minute, and if there is any question, I'll just put them on the stage, and if everything is fine, or else I'll just end the session.
Right.
I think you explained it quite well, sir. There is no questions.
Yeah. So anytime, it will be a pleasure. Anyone wants to get to learn about more about it, can reach me out. So it will be a pleasure to be interacting with each one of them. And like I told you that LinkedIn in the Brara, if you can just type in you. Uh, and there was one question: how do we measure the voice biometric system accuracy? So Samir, there are algorithms like I told you. So there's an engine like the deep learning engine, which is embedded in the algorithm itself. And while you speak, right, it actually gives you the accuracy of your speech. Say, for example, if your speech accuracy is less than 70%, I will not give you excess. So you can have that accuracy parameter set in the system itself. uh, and for the access. And if the accuracy is around 90% plus, I give you the authentication and gives you a go ahead. So there's an engine which works. I have not covered that engine part in particular because that was more technical part. So that's the engine which verifies the accuracy. So it's already there and taking care of it.
I hope that
Yeah, I
answers.
hope it answered your question, Samir. Yeah. Okay. There's one question, Bhavesh Kotwani. Voice of individual changes with age, say from teenage to adulthood. So there is a way to account for that. Yes. So what practically you do is anytime when you do a biometric portion of any person. So remember that the biometrics of kids is different from the adults, and a biometric of adults is different from the old. Okay. So you cannot have like once you authenticated, you are able to have the same authentication go all along. So always you do authentication 1 to 18, and thereafter from 18 till you're adult, maybe around 50, 55, you have that authentication parameters really do well, they remain the same. And if you have to onboard a person, if 55 plus in the on the or the 60 plus, then you have a different kind of parameters which come in. So but what happens is the basic parameters still remain same. So when we analyze, I showed you the frequencies of a person, so those remain same. The amplitude and the modulation may change, right? So that is what can be done. How do we identify the voice proxies? So there's a deep learning algorithm which is there, Bandi, which does check on the voice proxies. And like I told you in my last slide also, people try their best to overcome the challenges of spoofing and kind of imitating others. That deep learning algorithm actually verifies the database. It does the accuracy part of it. There's a NLP algorithm which runs over it. It kind of checks on a person whether he's the same person or not. And second thing which is there, like I told you, there are 70 to 80 points. Like I am talking right now also, if you have to do the voice biometric on mine, there are 70 to 80 nodes which are there, which are taken care of while we are doing the voice biometric solution algorithm which is running in the backend. So those are the points which actually identify. And the other part is it is not just analog what we are keeping. It's being kept in a hash code. Okay, and that hash code will only match if you are okay with whatever voice is coming in, right? So that is where the accuracy really goes up. So we use lots of conversational AI tools in the backend to identify people. I hope it answers your question. And if you really want it, definitely you let me know. It will be a pleasure to answer and reply to your queries. Anything else? Any other question? Right.
So thank you, sir. I think it was a pleasure having you here. And we at Sarthi also work in the field of voice biometrics. So definitely this information was quite enriching, and uh, I would like to connect with you in future. And thank
Sure
you very much.
enough.
Thank you.
Sure.
Thank you.
Thank you and have a great day and have a very successful session today.
You too, sir.
Bye
Thank you,
bye.
sir.
Have a great day.
Have a good day,
Bye.
sir.